In this lecture, we are going to understand the meaning of horizontal range. What is it and how it can be calculated if we have been provided initial velocity of projection, angle of projection, and the knowledge of acceleration, which is here, especially in this particular case, we have acceleration to be equal to g along negative y direction, because here we are taking y direction to be along the vertical, with vertically upward to be positive y, and along the ground we are taking x coordinates or x axis. So to get the range along the ground means up to what distance it reaches its flight completes. So just the first question that arises, that what is the meaning of range here? Here, horizontal range can be taken in easy words as x displacement in its complete flight. If we consider this projectile to have initial velocity or velocity of projection u at an angle theta with the horizontal, then by taking x and y direction to be along horizontal and along vertical respectively, we can easily resolve its motion into two independent motions along x and y directions, as we have done earlier also. Here also we may write the same equations for this projectile too, and as we know, horizontal velocity of this projectile Vx, it is always u cos theta, because this projectile do not have any acceleration along x direction. So throughout the flight of this projectile, its horizontal velocity remains constant. Now we have earlier achieved the time of flight for this projectile, and the time of flight which we had achieved was capital T equal to twice u sine theta divided by g, where g is the acceleration due to gravity under which this particle is performing this projectile motion. So by taking these two values, we can get this horizontal range. R is equal to horizontal velocity into time of flight. As there is no acceleration along x direction, so it can be written as u cos theta multiplied by 2u sine theta divided by g. So horizontal range R becomes Vx, horizontal velocity, into time of flight, which becomes, when we put value of Vx to be u cos theta and value of time of flight to be 2u sine theta by g, from here we get u square sine 2 theta divided by g, which is the desired value of the horizontal range along the ground where this projectile finally lands. If we talk about a practical example in which a projectile is fired with velocity 20 meter per second at angle 37 degree from horizontal, find horizontal range of projectile. Here you can see we have been provided a very simple case in which a projectile is fired from the ground itself. It again hits on the ground, and we have to find the distance between point of projection and point where landing occurs. So using the same formula which we had evaluated under this condition, range R is equal to u square sine 2 theta divided by g. Here this formula can also be elaborated as u square sine 2 theta can be written as 2 sine theta cos theta divided by g. Now you can see here theta has been provided to us to be equal to 37 degree, by using which we can get sine theta to be 3 upon 5 and cos theta to be 4 upon 5. U has been given to us as 20 meter per second. Value of G is well known to us. We can take it to be 10 meter per second square, or here the value of G is not stated, so we are taking it to be 10 meter per second square, as it is understood because the value of G is almost equal to 10 or 9.8 meter per second square. So for easiness of calculations, I have taken this value as G. By putting these values into this formula, we can easily write R equal to 20 square. Basically, I have taken here value of u to be 20, so 20 square, then 2 times sine theta is 3 upon 5 here, into cos theta is 4 upon 5, divided by value of g, which is 10 here. So we can get that range R is equal to 40 into 24 divided by 25, or 38.4 meter, which is the desired answer for this example. I have used a formula from the trigonometry for this sine 2 theta. I have written 2 sine theta cos theta.